Chapter 16, Thermodynamics. Let's get into it here. So, starting off here, just some general conversation about energy. Do you think it's possible to get energy for nothing? Is there such a thing as a free lunch? Can you get some kind of energy without having to pay in some way or another? And the answer to that is no. There is no free lunch. You can't get energy for nothing. Even in a situation like this, where you have, this is the Hoover Dam, and it seems like you might be getting energy for nothing because, the water is there. All you're doing is just making the water flow over the turbines and that would then turn them, and which would produce electricity. Even in that case, it's not actually free energy, because even though we don't have to pay the water to run over the turbines, scientifically speaking, energetically speaking, they are losing energy as they do that. There's always something that has to give energy when you take energy out. You're never going to get more energy out of a system than what was put into it. The reason the water is there in the first place is because the sun, shot a whole bunch of photons onto the ocean, and those photons heated the ocean up, which caused the water to evaporate into the sky. There was winds in the sky caused by, again, the sun heating one part of the atmosphere more than the other, which then caused the wind to blow that water over land, where it then precipitated in the form of rain and fell onto the ground and collected into the river and then was deposited behind the dam. So there was quite a bit of energy put into moving that water from the ocean into this reservoir. So even though it seems to us like the water is free, or getting the water to flow over our turbines and produce electricity is free, scientifically speaking, it's not free. Something had to put energy into that water to get it there at that higher elevation for us to take advantage of that and let it flow down to the lower elevation, and that is the sun, usually, is where we get that energy from. So when we're talking about energy and how energy moves around, you should kind of be familiar with some of this stuff from Chem 1, if you remember that from last semester. One thing that you should have at least briefly considered in Chem 1 was the first law of thermodynamics. And what this tells us is that the total energy of the universe is constant. Another way of putting this is that you can't create or destroy energy. The only thing you can do is transfer it from one place to another, or convert it from one form of energy to another form of energy. We can do both of those things, but you can never destroy energy or create energy out of nothing. The total amount of energy in the universe is constant. There's a nice little joke here about thermodynamics. People say, "Close the door, you're letting the cold in." Batman says, "No, you're not. Heat is going out." Because if you remember from Chem 1, again, something you should have discussed in Chem 1, is that when we're talking about thermodynamics, we're talking about heat. Heat is something that can go from one place to another. Cold is not a thing. Cold is just the absence of heat. We're going to start our conversation here about thermodynamics, kind of what might seem like in an odd place. We're going to talk about spontaneous processes versus non-spontaneous processes. Everything in the universe is going to fall into one of those two categories, either a process that occurs spontaneously or a process that does not occur spontaneously. And what a spontaneous process is anything that can proceed without any outside intervention. Essentially, if it can happen, it does happen. That is a spontaneous process. So for example here, if we have a flask where we have two sides of the flask that are separated, and we have gas on one side and just vacuum on the other side, if we open the stopcock to allow the gas to move, if it wants to, it will spontaneously fill both sides of the container evenly. All it has to do is have the possibility for that to happen. Us turning the stopcock is not going to be deemed outside intervention. All that's doing is allowing it to happen. It's not causing it to happen. And so because the gas moves and fills the two sides evenly, that is a spontaneous process. It happens without us having to go in and move the gas from one side to the other. On the opposite hand, if we somehow get all the gas over back onto side A here, that is not a spontaneous process. That will not happen just all on its own. Is it theoretically possible that all the gas could just go to one side of the container? Sure, yeah, it's theoretically possible. Will it ever happen? No, it will never ever happen. That is not a spontaneous process. There are very legitimate reasons, statistical reasons why that could never realistically happen, even though it is theoretically a possibility. So a spontaneous process is, again, something that happens without any outside intervention. Some other examples here. If you have some eggs and you're holding them in your hand and you let them go, if you're holding those up above a counter, they will spontaneously fall and crack on the countertop. You don't have to do anything to those. All you have to do is just give them the option, essentially, give them the possibility of doing it, and they do it. They fall, they hit the table, and they break apart. No outside forces needed for that to happen. You don't have to do anything to get that to happen. Is it theoretically possible that they could jump back up into your hands? Not without something crazy happening, not without some outside force coming in and causing that to occur. Same thing here with a car. You could have a really nice car like this. Nice old hot rod type thing, and it could, if you just stuck it out into a field and just left it alone for 20 years, it would turn into a pile of junk. And that happens spontaneously. You didn't have to do anything to it. You didn't have to go out there and whack on it with a bat or anything like that. If you just leave it alone, spontaneously, over a period of time, it will erode and rust and become a hunk of junk. Is it possible for that car to go back to being a relatively nice car? Yeah, it is. With a lot of work. A lot of hard work and getting the buffer out and getting all that rust off of it and repainting it. And you could take a really nasty beat up old car and turn it back into a nice looking car, but it would take a whole bunch of outside intervention. You will never spontaneously see an old rust bucket just now it's a nice car again. It's never going to happen. So these processes where in one direction is spontaneous, by definition, the reverse process cannot be spontaneous. Otherwise, you'd have you have a car turning nasty and then immediately getting nice again and then going back to being an old car and then going back to being nice. You'd have things jumping back and forth and back and forth and back and forth. That never happens. That doesn't happen in nature. So any process that is spontaneous in one direction, by definition, cannot be spontaneous in the opposite direction. One other thing here about things that happen spontaneously. Just because something happens spontaneously does not mean that it happens quickly. You might have noticed on the previous slide there when I said, you stick the car out in the field, it doesn't turn into an old rust bucket overnight. It does take some time. And some things that are spontaneous take a whole lot of time. If you have a diamond ring or diamond necklace or diamond earrings, the diamond in that piece of jewelry is actually less diamond than when you got it. Because diamond, spontaneously, at room temperature and pressure, turns back into graphite. It is extraordinarily slow. Your diamond is probably not even a nanogram less diamond than it was when you got it. It is very, 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 very slow. That being said, it is still a spontaneous process. The diamond is very, very slowly turning into pencil lead, unfortunately. But it is so incredibly slow that you would never be able to actually notice that it's happening. yes, and then one last thing here quickly. I forgot about this one. Spontaneous processes do change with temperature as well, and pressure as well, but we're not going to worry about pressure for this class. So something that is spontaneous at one temperature will possibly, not always, but possibly be non-spontaneous at another temperature. So water, for example here. Below 0 degrees C, water will spontaneously turn into ice, and above 0 degrees C, it will spontaneously melt and turn into liquid water. The only difference there is the temperature. Everything else is the same, but at one temperature, one process is spontaneous, namely at high temperatures turning into liquid is spontaneous, and at low temperatures turning into solid is spontaneous. So the temperature does matter. Temperature will have an effect on whether a process is spontaneous or not. Alright, in the next video here we will talk more about spontaneous processes, talk about the difference between an exothermic spontaneous process or an endothermic spontaneous process, and get into entropy and how that has an effect on spontaneity.